Okay, guys, here we go. Part 2. Continuing on. Number 11. A realtor who takes a listing on a house to be sold knows that she will spend $900 trying to sell the house. If she sells it, wait, sorry, guys. Let me zoom out so you can see the whole thing. She sells it, she earns 6%. If another realtor sells house from her list, first realtor will only earn 3% of the price. If the house remains unsold after 6 months, she will lose the listing. Suppose the probabilities are as follows, and blah blah blah. Okay. So for this one, there's two ways to do it. There's the first way, which either like in one of the versions of this class I talked about, is you do the values, multiply the probabilities, and at the very end you can subtract the cost. What I'm gonna do is I'm gonna subtract that cost to get the actual values in each case. So first case, if you sell $165,000 house, multiplied by 0.06, that means the profit is 9,900, but then you have to pay 900 to do that, right? So the net result is 9,000. That's the first value. Second value, 165,000 times 0.03, but then minus 900, you're net 4,050. Third outcome, she doesn't sell the house, means she doesn't get any money, but she still has to pay the $900 towards trying to sell it, and so you're out negative 900. So your three values are 9,000, 4,050, and negative 900, and their probabilities are given to you. So we'll just multiply it and add 9,000 times 0.5 plus 4,050 times times 0.3, and plus negative 900 times 0.2. And the end result is 5,535. So there it is, number 11. Number 2, what are the odds in favor of drawing a king? Remember, whenever you have these odds questions, I recommend to make the S, F, and T. In this case, S is equal to the number of kings. That would be 4 kings. Let's skip to the total. The total is 52 cards, which makes the failures 48. 52 minus 4 is 48. Right? So what are the odds in favor of drawing a king? Odds in favor are 4 to 48. Successes versus failures, right? And if you'd like to reduce that, you can reduce that. That'll be divided by 4, 1 to 12. Okay, number 13. Consider flipping coin 7 times. How many outcomes are possible? 2 to the 7th. 2 to the 7th. Which is 128. Okay, let F equal the event of attaining at least one tail in 7 flips of the coin. What does F not represent, or the complement of F represent? The probability of not F, it's the probability of not F, means obtaining 0 tails in 7 flips. What's the probability of that? Well, there's only one way to get 0 out of 128. It says enter fractions, okay? And then find the probability of F then. Probability of obtaining at least 1 would be 1 minus that, right? That's remember the law of complements? Probability of complements. It would be 1 minus 1 out of 128, which is 127 out of 128. Okay, that's it. Number 14, 5 coins are tossed. Odds against. Okay, so another odds question. So I want to make sure I have my S, F, and T. Odds against getting 5 hits. Okay, well, how do you get 5 hits? That's going to be equal to, well, actually, to get all 5, there's only one way to get all 5, right? What's the total? 2 to the 5th. We've seen that enough times now. I'm not going to explain it much more than that. And then 2 to the 5th is 32. There's only one way to get all 5. That means there's going to be 31 ways to not get all 5, right? Not get all 5 hits. How many different outcomes are possible? 32. How many outcomes are possible with 5 heads? Only 1. How many of these possible outcomes are not 5 heads? 31. So what are the odds against? Odds against is failures to successes, right? That's 31 to 1. Number 15. The probability of drawing a spade from a deck of cards is 1/4. Okay, another odds question. What are the odds in favor of drawing a spade? And they're already giving us the probabilities. That makes it easy. they're giving us a probability of drawing a spade, which means the S is 1, and the total is the denominator, that's the 4, which means failure would be 3. So odds in favor would be successes versus failures. Odds in favor of drawing a spade, yeah? 1, 2, 3. One for every one card that's a spade, 3 or not. Number 16, suppose the probability of the event is 0.6. Consider the process to find the odds in favor of this event. First, identify the following. Okay, so in this case, usually when I say odds, I always like to do the SF&T, and actually in this case, it is still possible. I'll show you how in a second. Okay, first let's do what they ask. This is probability of E is 0.6, just given to us already. The probability of not E is 1 minus that, or 0.4. Yeah, 0.40. Now, how am I going to do SF&T here? I'm going to do a little sneaky way. So 0.6 is the probability of E, right? But if you convert that to a fraction, that's 3/5. 3/5 probability means the S is 3 and the total is 5, which means failure is going to be the leftover is 2. So what are the odds in favor? S to F, 3 to 2. Okay, number 17. If that's too fast, just go back and rewatch it. Okay, number 17. Suppose events A and B are independent. Probability A is 1/4. Probability of B is 1/5. Okay, if events are independent, that means the probability of A and B is just simply the probability of A times the probability of B. Since they're independent, right? I don't have to worry about the given A part. I don't have to worry about this extra part since they're independent. So what's that then? It's going to be 1/4 times 1/5. That's 0.05, or if you like 1/20th. And that's the probability of A and B, but that's not quite what they're asking. They're asking for the probability of not A and B. So at the end, I just do 1 minus 1/20th, and I get 0.95, or what's a fraction, so it's going to be 19 out of 20. Okay, last 3 questions. Number 18 says, suppose B and C are independent. Again, independence. So what's the probability of B union C complement? Okay, so there's a couple things we need to do first. First, we need to figure out what's the probability of B and C. Why do I need that? Well, okay, looking ahead, watch. The probability of, because I can't draw this line over the top, I'm just going to say not B union C. So the probability of not B union C, this is what I'm after in the end result, right? That's equal to 1 minus the probability of B union C. Right? That's the law of complements. And what's the probability of B union C? Okay, well, according to my notes, probability of a union is the probability of the first thing plus the probability of the second thing minus the probability of their intersection. Right? This is just following what I know from my 13.4 notes. Okay, so since I have this, in order to get the probability B union C, I'm going to need the B and C first. And that one's easy because I have B, F, C, and I know they're independent. So I just got to multiply them out together. 1/4 times 1/12. Okay, that's B and C. Actually, let's do that in a separate line here. So B and C is this right now, right here, 1 out of 48. Yeah. And that means when I'm just going to plug it in here, that's 1 out of 48. And probability of C was given to me at the start, that's 1 out of 12, as was probability of B, that's 1 out of 4. So probability B union C is going to be the result of those 3 things. And that's 5 out of 16. So now the final result is just going to be 1 minus 5 out of 16. And it wants it as a fraction. So click the fraction button, and I got 11 out of 16. Okay, last 2. Suppose a die is rolled twice. And let the first toss, the A is that the first toss is prime, B is the first toss is a 5. Well, this is both referring to the first toss, right? So even though it's rolled twice, it actually doesn't matter. I don't even care about the second die roll. I'm just looking at the first die roll. It's probability of A and B. So in this case, A and B are not independent because they affect each other, right? So probability of A and B is probability of A times the probability of B, given that A has happened. And what is that? I'm gonna have to write it like this: B given A, because it doesn't like to me to write a single line. So what is probability A? Probability A is tossing a prime. What are prime numbers? From 1 through 6, the only primes are 2, 3, and 5. So the probability of prime is 3 out of 6. There's 3 numbers that are prime out of 6 outcomes. Now, supposing that I've rolled a prime number, it means supposing that I rolled a 2, a 3, or a 5. What's the probability that it's a 5? Well, it's only one outcome out of 3 outcomes. Okay, so my probability is 1/6. The other easier way to do that, though, is to look at my full. So, okay, so the answer is 1/6 using the formula for and probability. To me, the easier way to look at this is what's the probability that something is prime and a 5? Well, you look, there's 1, 2, 3, 4, 5, 6 outcomes from a single die roll, and only 5 is a prime and also 5, so it's only 1 out of 6. That's the easier way to do the same question. Either way, you get 1 out of 6. And that brings us to the last question. Assume a jar has 6 red marbles, 3 black ones. Draw 2 marbles with and without replacement. And find the requested probabilities. So probability of 2 red marbles with replacement. Okay, so how many red marbles you got? You got 6 red. And there's 9 total, right? 6 plus 9. So the probability that you pick first one red, 6 out of 9. And then you put that thing back. And then you draw it again. So with replacement, it's going to be 6/9 the second time you draw as well. I want that as a fraction, that's 4/9. Okay, without replacement, this changes slightly because there's going to be 1 less red marble to pick. And there's 1 less marble overall. So it's going to be 5/12 system. That's the first question. Okay, question number 2, or letter B. The probability of 2 black marbles, essentially the same question, except it's just 3 black marbles out of 9. And if you replace it, second time you go to draw, again, 3 out of 9. That gives you 1 out of 9. With replacement, it changes slightly. There's 2 black marbles after the first time you pick one, right? And 8 marbles overall, so it's going to be 1 out of 12. Okay, letter C. Letter C is actually the hardest one because you got to think very carefully. How can I get 1 red and 1 black? Well, the first one could be red, second one could be black, or the first one could be black, second one could be red. You got to consider both possibilities. So let's do the red first and black second first. With replacement. With replacement, first time I pick a marble, I've got a 6 in 9 chance of picking a red. And then assuming that I replace the marble back, I go to pick a black marble, that gives me a 3 out of 9 chance to pick the black marble. That's if the first one is red, second one is black. But I got to add that to the probability of the other thing that could happen, which is I could pick the black first. And then so I got to reverse it. It's 3 times 3 out of 9 times 6 out of 9 this time. Yeah, that's 4/9. That's the first question. Okay, if you do not replace, so without replacement, this is going to change slightly. If I pick a red marble the first time, there's going to be 6/9 for that first pick. But the second time, when I go to pick the black marble, there's actually still 3 black marbles. That part doesn't change, but the bottom changes because there's 1 less marble overall. Okay, and what happens when let me add some parentheses to kind of separate these 2 events here. So this one represents picking a red and then black. Here I have black first and then red. This time, if I pick a black marble first, that's 3 and 9's possibility. When I go to pick the red marble, there are still 6 red marbles, but there's 1 less marble overall. So that one changes to 8 on the bottom, and the result is 1/2. Okay, last question. Suppose it's a probability red on the first and black on the second. So this one's actually easier than the previous one. I can ignore this second possibility. Red first, black second. With replacement, it would be 6/9 the first time to pick the red marble, and then 3 out of 9 to pick the black marble. So that's 2/9. Without replacement, there's going to be 1 less marble overall, but still 3 black marbles to choose from. So 6/9 times 3/8 is 1/4. All right, let's check. We're checking 11 through 20 here, yeah? Okay, 11 is good, 12, 13, 14, 15, 16, 17, 18, 19, 20. Sweet. All right, guys, that's it. Good luck on the upcoming exam, and I will see you soon. Bye bye.